All right, so we're going to take a look at graphing square root, cube root, and cubic equations. And just to take a look at your transformations for each of these are your formats that we can put these in for transformations. Notice the a value is the same in each of these, which is in front of the actual function. Now remember that with transformations, anything that takes place inside of a grouping symbol, like right here, or right here, or inside these parentheses, anything that takes place inside your grouping symbol is going to be a horizontal transformation or a left to right transformation. Anything that takes place outside of your grouping symbols, such as the A and the D values, those are going to be your vertical transformations or changes the graph vertically. A in each of these is your vertical stretch or compression by a factor of A, and if the A is greater than 1, that will make it a vertical stretch. If A is between 0 and 1, it will be a vertical compression. And if A is a negative number, which means A is less than 0, then you will have a reflection over the x-axis as well. So the A value can do two different transformations for these. The horizontal, same kind of thing, except it is the opposite rules from a vertical transformation. So it is a horizontal stretch if B is between the values of 0 and 1. So it's the opposite rule from the vertical. And it's a horizontal compression if B is greater than 1, and it's by a factor of 1 over B. So it's the reciprocal value that you're multiplying by. And if B is a negative number, then that makes it a reflection over the y-axis. All right, so then we have your C values, which are your shifts inside here. Those are your shifts to the left or right. If you see a plus C in your equation, like a plus 5 or a plus 2, that would be a shift to the left. And if it's a minus C, that would be a shift to the right. The D value is outside of the grouping symbols, so that's a vertical shift. So if it's plus D, like plus 10 or something, that's going to be a shift up. And minus D would be a shift down. All right, so let's take a look at some actual equations and figure out the transformations or list the transformations on these. All right, starting with g of x right here, we have a negative right here, and it is located on the a value. That makes it a reflection over the x-axis. Then we have the 3 right here, which is a vertical stretch by a factor of 3. Then we have the 6, which is our C value, and that is a shift to the right 6 units. And then we have the 1, which is a plus 1, that's our D value, so that would be a shift up 1 unit. All right, so those will be the transformations for this graph. The cube root on here, this is not a transformation. This just tells you what kind of graph you would be graphing. Okay. All right, so the next one, f of x, has 3 transformations. The first one is the 2. That is a vertical stretch. by a factor of 2. And then we have this negative inside here. Now this is your b value, and the negative on the b value tells you it is a reflection over the y-axis. And then the 1/5 is also part of the b value. That's between 0 and 1, which makes it a horizontal stretch by a factor of 5. All right, so the next one, h of x, we have the 1/2 right here. That is a vertical compression by a factor, that is your a value, by a factor of 1/2. Now, what we have inside here, what we need to do with this is, since there is a number in front of the x, we have to factor that 3 out of both of these terms, which now makes it 3 parenthesis x plus 4. See, that puts it into this format that we have right here, where you have a parenthesis and you've got a number in front of your x. So in this format, that 3 is going to represent the b value, and the 4 is going to represent the c value. All right, so the b value here is 3. So that means we will have a horizontal compression by a factor of 1/3. It's the reciprocal value on the b. All right, so now we have this 4 right here, and it's plus 4, which means it is going to be a shift to the left 4 units. And then we have our d value, and it's a minus 4, so therefore it is a shift down 4 units. All right, so now we have r of x. All right, so the 3/4 is our a value. So that is going to be a vertical compression by a factor of 3/4. Now once again, you'll see that we have 2x plus 6. We have a number in front of the x, just like we had right here. Therefore, we have to factor 2 out of both of these terms right here. What that will make this is now 2 parenthesis x plus 3 and then cubed. All right, so that means this 2 is your b value, making that a horizontal compression by a factor of 1/2, the reciprocal value of 2. We have this 3, which is a plus 3, therefore it is a shift to the left 3 units. And then we have this minus 1, which is your d value, so that's going to be a shift down 1 unit. All right, so what we want to do now is we want to make take a look at graphing, and we're going to make a table first and then sketch the graph using the table. And we'll also talk about the transformations here as well. All right, so when you are dealing with square roots, what you want to do is plug in numbers for x that are going to cause you to have a square root of a number that comes out evenly. Now, numbers that come out evenly for square roots would be things like square root of 0 comes out evenly, square root of 1 comes out evenly, square root of 4, square root of 9, and square root of 16 are some numbers that come out evenly. Now, square root of 0, that's going to be the smallest number that we can take the square root of. So let's start with this one. All right, so what value do we need to put in for x in order for this to come out to be square root of 0? Well, what we would have to put in for x would be a -4. Because if we put this -4 in for x, that gives us -4 plus 4, which is 0. Square root of 0 is 0. The negative does not affect that. And then you have a plus 1, so that gives us a y value of 1. All right, so now we want to try to get a square root of 1. In order to get a square root of 1, my x value needs to be a -3. So that's what we put next. So -3 plus 4 is 1. The square root of that is 1. This makes it -1. And then adding 1 to that makes it 0. All right, so we now want to get a square root of 4. To get a square root of 4, our x value will need to be 0. All right, so that'll give us square root of 4, which is 2. This makes it -2. And -2 plus 1 is -1. We now want to get a 9 underneath the square root. So that means our x value needs to be 5. That'll give us square root of 9, which is 3. This makes it -3. And -3 plus 1 is -2. And then lastly, we want to get a 16 under here. So that means the x value will need to be 12. Giving you square root of 16 is 4. This makes it -4. And -4 plus 1 is -3. All right, so if we sketch a graph of the points here, we have -4, 1, which will be a point right here. Then we have -3, 0, 0, -1, 5, -2, and then 12, -3 is off of my graph, so I'm not going to worry about sketching that point. Okay. All right, so if we draw the graph going through those points, it looks something like this. Now notice the transformations. This is a shift to the left 4 and up 1. That is the location of the endpoint for this square root graph. We're going left 4 and up 1. The negative is your reflection over the x-axis, which means instead of going up like the normal square root graph, it's going to go down. All right, so the negative did not affect the location of the endpoint. It just changed the direction of the graph. The only transformations that will affect where the endpoint is located are your shifts. Okay. All right, so let's take a look at the next one here. All right, so I'm going to go a little bit faster on this. We want a 0 under here, so that means we're going to use an x value of 0, and that will give us a y value of -5. Then we want this to be a 1, So that means x will need to be 3, and that will produce a y value of -4. Then we want this to be a 4, which means x needs to be 12, and that will give us a y value of -3. Then we want this to be a 9, because that comes out evenly, so the x value needs to be 27. That will give us -2. And then 48 will give us a 16 under here. Square root of 16 is 4, and 4 minus 5 is -1. All right, so plotting these points, we have 0, -5 right here, 3, -4, 12, -3, and the other points are going to go off my graph, so I'm not going to worry about graphing those. And that is a sketch of your square root graph. Now, again, notice the only shift we have is down 5 units, and that is the location of the endpoint. The 1/3 does not affect where the endpoint is located. All it does is it affects the curvature of your graph. It does not affect the location of the endpoint. All right, so the next one, kind of doing the same thing here. This time we are looking at a cube root. Now, cube roots that come out nicely are going to be things like the cube root of -8. That comes out evenly to be -2. The cube root of -1 comes out evenly to be -1. Cube root of 0 works out nicely, and the cube roots of +1 and +8. Those are some nice cube roots that we can use on this. So in order to get a cube root of -8, we need an x value to be -5. Because -5 minus 3 would be -8. Cube root of that is -2. Plus 2 gives you 0. All right, so now to get a -1, our x value needs to be 2. And that will give us a y value of 1. In order to get a cube root of 0, the x will need to be a 3. That will give us 0 here, and 0 plus 2 is 2. All right, so then we want to get a +1. So to get a +1, the x value needs to be 4. And that will produce a y value of 3. And then to get a +8, x will need to be 11. And that will produce a y value of 4. So plotting these points, we have -5, 0, it's right here, 2, 1, 3, 2, 4, 3, and then let's see, 5, 6, 7, 8, 9, 10, 11, 4. All right, so sketching our graph going through these points. Kind of looks like this. All right, so the next one is going to be a cubic graph. And so with this, we're not really as concerned about it coming out evenly because we're not dealing with radicals. So we can pretty much plug any number we want in for x, and it's going to work out nicely. The only thing is we want to try to keep our numbers relatively small so that it fits on our graph. All right, so let's try -1 for an x value, because -1 plus 1 is 0. That keeps everything nice and small. and negative 1 plus 1 is 0, cubed is 0, times a half is still 0, and then minus 4 will give us negative 4. All right, so now let's try 0. 0 for an x value will give you 1 cubed, which is 1. 1 times a half is a half, and then a half minus 4 will be negative 3. All right, so let's try 1 now. 1 plus 1 is 2, cubed is 8, times a half is 4, minus 4 is 0. Now, if we plot these points to get an idea of where we're at with this, we see negative 1, negative 4, 0, negative 3, and 1, 0. We can see the trend of our graph, our cubic graph, going up like this. And so I don't really want to go any further to the right. I mean, I could, but it may or may not fit. I know what's basically the trend going on here. So what I know also is that my cubic graph has to go down like this over here. So I need to find some more points over here that are going to be plotted so I can get a better idea of what it looks like. So let's, instead of going to the right, let's go to the left, and let's use an x value of negative 2. Negative 2 plus 1 is negative 1, and negative 1 cubed is negative 1, times a half is negative 1/2, and negative 1/2 minus 4 is negative 4.5. All right, so that's going to put us, let's see, I think I made a mistake up here. Let me fix something real quick. This should have been negative 3.5 on that problem. So let me fix that one real quick. Good catch on your part. All right, so now let's use negative 3. All right, so negative 3, when you plug it in, plus 1 is negative 2, cubed is negative 8, times a half is negative 4, minus 4 is going to give us negative 8. All right, so negative 4, 1, 2, 3, 4, 5, 6, 7, 8. And that gives us a sketch of our graph that looks like this. Now, with the cube root and the cubic graph, the point that we want to look at for transforming is this point right here. That's the point that on the parent function is at 0, 0. All right, so remember your parent function goes right here like this. Okay, so we're using this point from the parent function and transforming it so it is moving to the right 3 and then up 2, and that's our shifts right here. All right, so then that same point on the cubic graph, the cubic parent function looks like this, okay? And we're using that 0, 0 point here, and that point is being shifted down to here, and so that shift is to the left 1 and down 4. Those are your shifts right here, left 1 and down 4. All right, so now let's take a look at writing equations for the graphs. All right, so with this, we have a shift to the right, 1, 2, 3, 4, 5, and a shift up 2. And this is a square root graph. So I'm going to go ahead and write a square root, and it's shift to the right 5, which is an x minus 5, and then up 2. Now, the graph is also not going to the right like it normally does. It's going to the left, which means there has been a reflection over the y-axis. We show that as a negative on the inside. And let me draw this a little bit better here. All right, so we put our negative on the inside. That would be our b value needs to be negative in order to give us a reflection over the y-axis. All right, so the next one, again, these have no stretches or compressions on them, so I'm not worrying about that right now. All right, so this one is also a square root graph. This one has been shifted to the right 1, so that's x minus 1. It's been shifted down 5 units, so that's minus 5 here. And this one is going down, which means it has a reflection over the x-axis. Reflection over the x-axis, you put a negative on the outside of the square root. All right, so now these do have vertical stretches or compressions. So what we want to do with this is first identify what your equation would be with your transformations. Again, it's a square root graph, shifted left 2, so that would be an x plus 2, and shifted up 1, so plus 1. Now it says that there are vertical stretches or compressions. That means there will be an a value right here. In order to find out what this a value is going to be, we need to put some numbers in for x and y. Now, x and y just simply represent any point that is on your graph. Now, we do not want to use the endpoint because, well, that's going to end up giving you a 0 here and taking out the a out of the problem. We don't want that. So let's use this point that's given to us up here being on the graph, because that's going to intersect exactly, and that is the point 2, 1, 2, 3, 4, 5, 2, 5. All right, so what we will do then is we will insert 5 as our y value, 2 as the x value. All right, so that's going to give us the square root of 4, which is 2. So this is now 5 equals 2a plus 1. Subtract the 1. And dividing gives us a is 2. Now, since a is 2, we can take that and plug it back in to get our equation, which would be y equals 2 square root x plus 2 and then a plus 1. All right, so following the same idea on the next one, we're going to have y equals, and it is a square root graph shifted to the right 1, so that's x minus 1, and shifted up 3, so that's plus 3, and we will have an a value once again. Now the point located on this graph is going to be the point 10, 1. So that's what we're going to substitute in here. So we get 1 equals a times square root of 10 minus 1 and then plus 3. Now this will be a square root of 9, which is 3. So that makes it 3a. All right, so subtracting the 3 gives us negative 2 equals 3a. And dividing means a is negative 2/3. All right, so plugging this back in for the a, gives us our equation y equals negative 2/3 square root x minus 1 plus 3. All right, so these do not have any stretches or compressions on them. So what we are looking for is where our graph changes concavity, which is right here. That's the point that is being transformed from the parent function of 0, 0. All right, so that point is being shifted to the left 4 and up 1. This is a cubic graph. So since it is a cubic graph, we can have something cubed. Left 4 is going to be x plus 4, and then up 1 out here. And again, there are no stretches, compressions, so we don't have to worry about the A or B value on this. And then the next one, your point that we're transforming is right here. That is shifted to the right 5, and this is a cube root graph. And so we're going to have x minus 5 shifted down 2 units, so minus 2. There also is a reflection, and on the cube root, a reflection over the x-axis and a reflection over the y-axis will both produce the same graph. So we could put the negative right here on the outside, or we could put the negative on the inside. Both of those equations will produce the same graph. And then finally, if you have some equations here, we're going to generate some equations off of some written explanations on this. All right, so starting out with the first one, we have a square root graph. So we're going to start out with y equals. We know there's a square root. Now plug in the numbers as you come to them. We have a horizontal stretch by a factor of 2. That goes in as our b value of 1/2. Then we have reflected over the y-axis. Well, that means it's going to be a negative b value. All right. And then we have 6 units left. All right, so we put that as x plus 6 inside the parentheses, or in the parentheses underneath the square root. Okay. All right, so that's it. Next one. This is a cubic equation, so we can go ahead and put our parentheses cubed. It is compressed vertically by a factor of 1/3, which is our a value of 1/3. It is reflected over the x-axis, which means that 1/3 will be a negative a value. And it is 8 units down, which will be minus 8. What goes inside the parentheses then? Well, that's where our variable is located, and that would be x minus 0, because there is no shift to the left or to the right. And x minus 0 can just be written as x. Now, in this situation, because all you have is the x in there, you do not absolutely need the parentheses. You can just write it as negative 1/3 x cubed minus 8. This would be the same equation as this one. It's just that the parentheses are not necessary if all you have is an x. All right, so the next one we have is going to be a cube root. And this one is stretched vertically by a factor of 4. So the 4 is outside. Reflected over the x-axis. so that A value is negative. And finally, 3 units to the right, so that's going to be x minus 3 inside.